In the last servlet example that we saw, we were using the HTTP client library to send post and GET requests to the server. But if you've noticed, it took a lot of work, just like with the servlet, to be able to turn our logic into something that we can send an HTTP post request with. So we had to go and create an HTTP post, we had to create a bunch of name value pairs, and then URL encode them and attach them to this body and send it off to the server. And it really took a lot of work, and there was a big disconnect from the code that we were trying to write, which was add a video or get a list of the videos, and what we actually had to do in order to invoke that on the server and get the result back. Now, just like with Spring, there are ways to simplify that interaction significantly so that we don't have to write all of the low-level code to translate our desires in terms of method invocations and on the services that are in the cloud into HTTP methods. So right now, what we're having to do is when we want to send a message to our server, our client is having to go through and use a library to manually create the HTTP requests. So the interface that we're working with is the Apache HTTP client, which means that we're having to be exposed to all of the information related to how do you go and translate something like add video into HTTP. What we would really like to do is just directly call add video and then have whatever library we're using, this black box, automatically translate that into the appropriate HTTP calls that need to go to the server. Just like on the server, we can automatically see what parameters a method is expecting, extract them, create objects, invoke the method, and then convert the return type back into an HTTP response. We want to be able to do something similar on the client side so that we can do things in a more Java object-oriented way where we're just invoking methods, and because they have the right information, HTTP requests are being sent from them. And there's a number of reasons to do this, one of which is when we're dealing with the low-level details of like HTTP client, we can easily make mistakes. We can make typos in the strings that we're using for keys. We can easily have all kinds of situations where we're looking at the different response codes to figure out what to do. We'd really like to make it simpler and look like this so that we can have simple, easy invocations that look object-oriented to our code. Now we still have to account for the fact that these invocations are going to be slow because they're going across a network, but we would like to have the automatic translation. And that's what Retrofit is going to provide us in this code example, is Retrofit can automatically, if we give it the right annotations, translate our method calls into HTTP requests on our server that will be interpreted correctly by Spring. So let's take a look at how this works. So if you open up the video controller and Retrofit project again and look at the client package, the org.magnum.mobilecloud.video.client package, let's look at this video service API that we didn't look at before. Now, what you'll see is we're actually using Retrofit with this video service API. So we've created an interface, a Java interface, to describe the operations that can be invoked on our controller. In this case, we can invoke getVideoList and get a list of videos returned to us, or we can invoke addVideo and provide a video object, and we'll get a Boolean back if it's successful. And if you'll go and look, and we can open up and look at our controller class that we created, we'll see that our controller class actually implements this video service API. So we've created an interface that provides a strong contract between our controller, which is the server side, and our client, which is going to be the video service API side created by Retrofit. So we're going to use Retrofit to automatically create an implementation of an object that can, when these methods are invoked, send the appropriate HTTP request to the server in order to automatically translate the response body back into a list of videos, or automatically translate a video into a request body so that we can invoke the correct methods on our controller. So what we've got in this video service API is the get video list method has been annotated with the @get annotation that is provided by the Retrofit library. So all we have to do is tell it that whenever you invoke this, you should send a GET request, and here is the actual path to the request that you should be sending. So when you send a GET request, it's going to send a request to /video, which we also know is what our video service controller is bound to, the various request mappings. So you can see that the various request mappings are also bound to video service paths. So we know both our client and our server are going to be working with the same paths. Also added an @body annotation so that Retrofit knows that the video parameter that we're providing should automatically be converted into the body of the request that we're sending. And in this case, Retrofit's going to be converting that video into JSON and putting it in the body of the request. On the other side, we know that Spring is going to look at the body of the request, interpret it as JSON, and read a video back out. So we've got a nice contractor interface that we can use to allow us to automatically send requests in an object-oriented way to our server. Now, if we open up the video service client API test in the source test Java package, we can see how we use Retrofit and this interface together. First, at the top of the test, we create an implementation of this interface dynamically, or we ask Retrofit to create a dynamic implementation of this interface that will send HTTP requests in response to the methods on this interface being invoked. And the way that we do that is we create a new REST adapter builder, and then we set the endpoint to be our server, which in this case is localhost 8080. We set up some logging so we can see what's actually being sent to the server, and then we build and create a new implementation of the video service API that's bound and attached to this particular server. So what is actually happening behind the scenes here is Retrofit is creating an object that implements the video service API, and it's dynamically creating this object such that whenever you invoke one of the methods on the video service API, it's going to generate the appropriate request based on your annotations on that method and send it to the server that we've specified up here. So if we look a little farther down, what we see is we have an example where we're creating a URL, a title, and a duration for a video, just like we did before with our test that was using the HTTP client library. But rather than having to go into the low-level details of constructing a HTTP post request and using the client to send it, instead we just create a video object with those details and then ask the video service API implementation called video service to add the video. Now, a huge amount of work is happening behind the scenes to make this happen. What Retrofit is doing is our add video call is being taken and translated by Retrofit into a HTTP post request. And the way it's doing this is the interface that we're using up here, the video service API, is annotated with the various @post and @get annotations. And so when you invoke add video, Retrofit looks at add video and says what annotation is on it, and it sees @post. So it says, I know I'm supposed to create a post request for add video. It then looks at the value that you provide inside the annotation, which in this case is /video, and says, I know I need to send that request to /video. It then looks at the annotation inside the parameters and says, I know I need to take this parameter video and encode it into the body of this HTTP post request. So the video that's in here is going to be inserted as JSON into the body of this request. And then on the other side, Spring and your controller is receiving this JSON and able to do its own magic to extract that JSON into a video object and process it. Similarly, if the controller sends a response back, the Retrofit library can see the return type of add video and know that I need to take whatever is in the response body, interpret it as that particular return type so I can read it out of the response body as JSON and then convert it to whatever return type of the add video method we have. So all of this complicated work allows us to have this simple call that we see right here to videoservice.addVideo. And all of the details of how this method call goes and actually turns our video into an HTTP post request is hidden from us. And instead, we can operate using an object-oriented, nice, clean interface to our server. And then we can also go and similarly get a list of videos from the server. This is going to end up sending a GET request to the server to /video based on the annotations that we provided in our interface. So through some simple annotations, we're getting really powerful simplification of the work that we have to do in order to interact and send HTTP methods to the server. Not only that, but it's hard for us to mess up these requests because add video is a strongly typed Java method. So if we don't pass a video object in, this method would not compile. This method call would not compile. So if we tried to pass something else in. So we're not only getting a simple interface to go and invoke those methods, but we're getting type safety because our interface has strong Java typing on it. So we can't just go and invoke methods with the wrong parameter types or expect that the parameter coming back from the return value is of the wrong type. So you can see how Retrofit is doing a lot of the same type of work that Spring is doing, but it's doing it on the client side. It's making it easier for us to generate the HTTP requests from method calls that are going to the server. And similarly, take the responses that we're getting back and convert the response bodies back into objects that we can operate on. So it's substantially simplifying and improving the type safety of our interaction with the server.